All right, Benny boy. It's your turn to guess. And we're doing a frog call.
And it is a frog. It's sounding like a forest-dwelling frog. Yeah. I'm picturing very sort of damp rainforest-like conditions for these guys.
Yeah, you're painting a really magical picture there.
Yeah, frog, I would say, is about shoulder height, sort of elbow to shoulder height off the ground on medium to large leaves.
Okay.
It enjoys eating small invertebrates.
Yeah, it's a frog.
They have a very sort of tenacious personality.
Tenacious? Maybe.
Do I get any sort of clue?
I'll tell you, it's from Australia. A place where I happen to know you know not your most area, not your sort of best area of expertise with frog life.
I don't think any area is particularly good for frog life. My expertise.
Well, you've seen most of the ones seen a lot of the ones in Thailand, perhaps. But yeah, go on. You got any ideas here?
If you're gonna make a wild guess, chuckling bush frog.
All right, no, but not a bad guess for a name of a frog that might exist. No, so it is actually, in fact, the rain whistling frog. That is Ostrocaperina pluvialis. And this call was actually sent to us by Seb Hoofer, or the newly minted, actually, Dr. Seb Hoofer, who is an Australian herpetologist. And it came with a nice story, so I'll read it to you now. Seb said, "Here's the call of the rain-whistling frog, Ostrocaperina pluvialis, a little frog I had the pleasure of hanging out with in the Daintree rainforest in far north Queensland. A while back, I was frog spotting by a creek when out of nowhere, a heavy burst of rain hit. I quickly found shelter and just sat there listening to the drops. That's when it happened. An adorable little frog started warming up his call. First, it was just one, but soon a whole chorus joined in. Naturally, I abandoned my dry refuge without a second thought. Frogs better than staying dry, obviously, and charged into the rain to locate the little guys behind those irresistible calls. I thought this must be what the females feel like, except let's face it, the ladies are much better at finding them. I kid you not, I stood in front of this frog for a solid 10 minutes, hearing his call but completely failing to spot him. Finally, I caught a flicker of the little white vocal sac flickering, and there he was, in all his glory, proudly broadcasting his powerful call into the forest in an attempt to outcompete other potential suitors and gain the well-deserved attention of a female. And Ben, here's the picture of the frog, a cheeky little customer.
Absolutely adorable.
And yeah, Seb goes on to say, what a fantastic night and an even more fantastic frog. Sorry, I got a bit carried away there. Tuesday Procrastination at its finest. We love it, Seb.
No, it's painting a wonderful picture.
Yeah, it's a vivid image. And that's actually a female in the picture. Oh, no, it's not. It's a male. It's a male from his little cooling spot.
Right.
So that's where he was sitting. That's his little vocal
sort of
sack.
Chocolate brown frog. Very frog-shaped frog by the looks of it.
Right, yeah. You've really painted a picture for us there, Ben. Amazing. And it's a frog that looks like a frog, you said. Wow.
Yeah. Mm-hmm,
it really does.
And sounds like the sounds that we just heard.
Yes. I don't know what else there is to say about this frog. It's quite small and it sort of has a bit of a sort of white crest on its nose. It's a rainforest species. It likes low and high altitudes, usually found under fallen timber or leaf litter. And apparently they call from beneath leaves on the forest floor generally. So your assertion that it was high up in a tree, probably not true.
Cryptozoic.
Or at least shoulder height. Cryptozoic.
I stand by the tenacity comments, though.
Oh, sure, it's tenacious. What do you mean by cryptozoic? I can't remember what that means.
Dwelling in the leaf litter, right?
Dwelling in the leaf litter. Okay. All right. So let's move on. We are sticking on the theme of amphibians. We're talking about some American ones, actually. North America. So this is a Patreon topic for Kinga. So thanks very much, Kinga. Much appreciated. And Kinga said, I'm curious about species of salamanders that return to their natal pond or pool to breed. Have there been any studies that look at whether they ever go to different ponds? For example, what happens when their natal ponds are built over or developed so that the original pond is not available? So this refers to the fact that a lot of amphibians will like return to their pond from whence they came to breed.
Yeah, like sort of slimy turtles.
Like slimy turtles. Kinga goes on to say, or in contrast, if a pool or pond was polluted, overgrown, or the surrounding habitat was degraded, but has now been restored, will they find their way back? And I was specifically looking at Ambystoma maculatum, but would be interested in any relevant info for species of amphibians, especially salamanders. So, how individuals react to their natal pool, so the one they hatched in, so the ones they came from eggs to larvae and out, being paved over. Unfortunately, Kinga doesn't really seem to have been investigated in any great detail. We did have a good old route through the literature.
That we could, big caveat of that we could find.
Yes. Otherwise. Yeah, there might be something hidden away in a textbook somewhere, or we just didn't see it. But I don't know that there's been, because that would require quite a lot of detailed investigation, right? Like you'd need to follow an individual from coming out of the pond as a little salamander or frog. And then you'd have to track it, know that individual, maybe mark it.
Definitely
and then
mark
find
it.
I
don't think you'd need to actively follow it. I think you just need a really long-term mark recapture study on a site with sort of comparable controls that is undergoing that development.
Yeah.
But it'd be hard to commit to doing a long-term mark and recapture of a site that you know is going to be developed, sort of thing. But
yeah, it's a bit of an awkward one. And so we did try, and we found something quite similar. We did manage to find a long-term mark recapture study, which I think is quite cool and has some nice results anyway.
And has ambystoma.
And it is also, it does have ambystoma maculatum as well, the spotted salamander, very specifically, with maculatum meaning spotted. And so, yeah, let's introduce this one. Hopefully, Kinga, this scratches the itch. And it sounds like if you want a paper about that, you might have to do the research yourself one day. So yeah, this is by Winters, Wilson, Costa, Rothenberger, 2024, integrating population genetics with long-term environmental monitoring to evaluate and guide vernal pool creation for amphibian conservation, published in Ecology and Evolution.
So what's a vernal pool then? Give me your best definition of a vernal pool.
Vernal. Doesn't it mean sort of it goes away and then comes back?
Yeah. I mean, that's, yeah. I'm satisfied with that.
Where does vernal begin and ephemeral end is a good question that we should be asking maybe.
That is a good question.
Or are they synonyms? I don't know. Not sure.
I feel like ephemeral is on the more fleeting end of vernal. Specifically because I used the word ephemeral in the paper at some point when they're describing the ones that are patchier, as in don't come back as consistently, I believe.
Okay, so like an ephemeral pool could be like a tire track with water in it or something, and then a vernal
closer
pool
to
is
that
like
stuff, I think so, yes.
Vernal pool's established as a place where amphibians like to go. So yeah, we're talking about two different species of amphibian here. We've got the spotted salamander and the North American wood frog, which is Lithobates sylvaticus, also named well, wood frog sylvaticus. Sylvie things are to do with trees, aren't they? So that's another good name. And yeah, wood frogs are known to be highly philopatric. So they go back to the same pool. They always try and breed in a pool they've bred in before normally. Not always, but like they like to. And they have really well-developed homing abilities. They can find their way back. Apparently about 20% of froglets disperse to neighboring pools. So if you catch them when their baby's leaving the pool, most of them will come back to the same pool, but about 20% won't. They'll go to different pools. But if you catch an adult in a pool where it's going to breed, it will always come back to that same pool 100% of the time. So once they pick a breeding pool, they stick with it. They like it. They know it.
Right. Now, that's wood frogs. That's all well and good. But what about our spotted salamanders? So there's another paper that had a quick sort of look through. This is a Davis et al. Paper that's looking at it's a different mark and recapture, completely separate location, different whatevers, but it gives us a nice idea of how these spotted salamanders are doing, and it's not too dissimilar a picture. So I'm going to give you a few sort of metrics. For female salamanders, they're tending to stay at the same pool year to year. At a sort of 84% of them are returning back to the same pool. So that's, it's not that sort of absolutely going to go back to the same pool thing that you're describing with the wood frogs, but still, I feel like 84% is pretty high. Like, they've got some serious fidelity there of returning. Male is much more variable. So anything from like a 24 to a 93, depending on the individual. So males are the ones that are potentially more responsible for that genetic mixing between different breeding pools. So each year they're coming back and they're potentially picking a different pool. The other thing they checked out in this, because, okay, between years one thing, what about in one season? Are they visiting multiple pools like one year and then sort of going to other, or are they going to multiple pools within the same year? And it seems,
are they spreading those eggs around?
It seems to be that the males are pretty much picking one wetland or, one pool in a year and reasonably well sticking to it. So it's 94 to full on 100%, as in didn't change pool within the year. So that the sort of mixing and variation seems to be coming between years as opposed to within a single breeding season. If that makes sense.
Yeah. So, okay. So, yeah, they are... Yeah, okay. So they are mostly sticking to the same pools, but not exclusively.
Yes, I think that's the broad sort of pattern, is they do have this sort of returning to where they're used, but it's not complete.
Right on. Okay. And so we're talking about these breeding pools. So, these are amphibians which they have a larval stage. They're laid as eggs in these pools, and then they develop in these pools, and then they leave the pools. They're sort of little microcosms of the evolution of all of us, really. They leave the pool, and then they come out, and then they live in the woods mostly, and they eat insects and stuff like that. They hide under rocks and logs. Yeah, they have their best lives. And then when it's time, they go back to their vernal pools. And so one thing which has been used quite widely to try and help these amphibians is to create pools for them. So particularly if there are places where pools have been destroyed, then you can sort of create new pools as this kind of replacement habitat. But there's a lot of controversy about how well these replacement pools actually work. And, I personally am quite cynical about this kind of thing. Like, I think a lot of the ecological, and we always say this, like, not to discredit anyone who is an ecological consultant, because they are all universally, at least in my experience, like super, like, interested in what they're doing, and they're trying to do the very, very best.
Mm-hmm.
But like, you can't always, like, I feel like I've seen like badger sets and stuff that have been recreated, and I don't know, like sometimes they just don't always seem as good as they could be. And I don't know, yeah, that's a broad stroke, but essentially, if you're building ponds for these amphibians to try and recreate lost habitat, it might be the case that quite a lot needs to go into that. And obviously this is something which all consultants universally will be interested in learning.
Yeah.
But that doesn't mean that some of the pools which have previously been created they've not been perfect, right? And so these authors wanted to kind of take a bunch of these pools in this wetland, which has both natural and unnatural pools. Where was it? Jacobsburg State Park in Pennsylvania.
Yeah.
And they wanted to look at the kind of characteristics of these pools, but in conjunction with the genetics of the eggs and amphibians that they found there, and see whether there were any kind of signatures about what led to good success and what kind of might influence the genetic variation at these pools, which could indicate some kind of issue with them in terms of amphibians successfully breeding in them.
Yeah, and the whole genetic aspect was nicely justified, because they were saying, okay, so if you're monitoring these pools for success or something, egg mass, or something that's just describing some sort of reproductive output quite early doors might not really be adequate to determine whether these pools are working or not. Because you can have a whole bunch of eggs, but if none of them survive, well, it doesn't really mean that much. It's about that sort of actual recruitment sort of further down the line, and whether that's playing into the population or not. So there is a sort of mismatch with what's easiest to record and monitor, and actually what's beneficial for the animals. I think that's sort of touching on your point with the sort of consultancy thing, is people are, I feel like, quite frequently constrained with the time and resources they're provided for these sort of longer term, monitoring to see if these interventions have worked.
Yep. And they'll be promised things
you
they
just
don't
can't
get.
do genetics for every single site that you're improving, right? So there has to be some shortcuts, but this does highlight potentially some of the flaws with those metrics, possibly.
Totally, yeah. And that is always a problem, is like you have these like big ideas and you implement them, and like, it will look really good and it might be really good, but you don't monitor them afterwards to find out. And that means that you just never know. And that's because these big developments aren't interested in spending money for the ecologist to go and visit the same place 5 years after it's all been completed. Some of them do. I don't know that much about it. Yeah, but it's like there's not always a budget for that, and because once it's done, and everyone just moves on to the next housing development, and it's like, cool,
well, I think that's the real tragedy of it, and I think that these results that we're going to start discussing sort of pretty much hint at is that it's probably better to not remove the natural made ones to begin with, because you're never really going to. It's a hell of a lot harder to recreate something that was made naturally than just, I don't know, maybe not get rid of them in the first place.
Yeah, totally. So let's talk about what. So you mentioned that they were looking at not only the amount of eggs in the ponds, but also the success. So how many of those eggs turned into little baby amphibians and left the pool? Yeah, exactly. And so things that were important were hydro period. So like how long they're wet for, and this is something you got at earlier. They need to be wet for long enough for the eggs to develop and leave. Otherwise, they're just not. There is no time. So the larvae is still larvae.
Yep.
And this, it's like a tadpole maybe, and then the pond dries out, or the tadpole's not ready for land. It's just toasted. Also, things which kind of, I guess, sort of directly affect that are the volume of the lake. So how much water is actually in these, pools, not lakes, but how much volume of water there is. So like essentially the size. Also the depth. So the deeper they are, the better they are generally.
Which, I mean, and also, depth and volume, I feel like, speaks to all sorts of other sort of covariates there, right? Like, is that a sort of predator pressure thing? Is it sort of avoiding predators sort of thing? Is it a temperature stability thing? Is it the sort of, fluctuating water level thing? Because anything sort of like depth and volume are going to have, I guess, not just a linear relationship with some of those things, but an exponential, right? Because you've got this volume to surface area ratio thing going on, which is almost certainly going to make a more stable environment for these newly appearing salamanders and frogs.
Yeah, exactly. And further to that, they also needed to have good forest cover. So basically, when they come out of these pools as juvenile, or I guess they're not juvenile, they're basically adults by then, but they need to have forests nearby in order to sort of fulfill the rest of their life cycle. They need to have forests to hunt and find places for shelter. And so overall, although natural versus non-natural pools wasn't that big of a deal, it tended to be that the natural pools were better simply because they had this longer hydro period, more volume and depth, and better forest land cover around them. And so there was one pool in particular, actually, that was human created that was really good for amphibians. One of them was sort of almost equivalent to the natural ones in terms of the success of the amphibians. But the others that they checked, the other sort of 2 or 3 that they did, weren't as good. And that's probably just because, the people who created them didn't know what they needed to include in order to have success.
Or they did, and it just wasn't, the job wasn't done very well. Like there's any number of steps along that process that could go a little bit awry to basically make something that's not going to do the job adequately, right? Like it's more than just a knowledge gap here.
Yeah, but let's talk about the genetic one. So you mentioned earlier that there can be a problem if these frogs or salamanders find a pool to breed in, lay their eggs in, even they don't know whether their eggs eventually go on to hatch because they leave, they get out of there before the pool dries up. So it could be a case that there's this kind of ecological trap. And generally the survival of amphibian larvae was higher in natural pools, but also there's one pool in particular showed a bit of a genetic bottleneck for the wood frogs. So It's a shallow pool. It had low water volume. It dried out quite early in June. So the juveniles were never emerging. And it probably just has the same group of adults kind of endlessly returning to it and breeding there, despite the fact that their eggs never survive to adulthood.
Yeah, exactly. That's super, super low survival. Yeah.
And so this causes this signature of reduced genetic variation because you just have few adults which are just like repeatedly returning there. And the other pools, including the ones which had been built by people, actually look pretty good though. And they seem to have sort of good admixture of genes between them, and they seem to be kind of broadly successful.
I think what's sort of also adding to that bad pool, that genetic bottleneck sort of ecological trap pool too, is judging by the Davis paper with the movements, is potentially that they're almost less likely to get other individuals sort of checking it out and transferring to that pool because of its, the other limitations, be that volume and depth and sort of other things that they may be choosing these pools preferentially for. So there's a lot of factors that could be sort of doubling down on making that artificial pool in particular particularly not brilliant.
Yeah, exactly. So we can make good pools. We have the technology.
Yeah.
Just have to dig them deep enough to make sure they don't dry out. Ensure there's enough good woodland nearby for these little amphibians to find the bugs when they're not in the water. So there we go. Ambystoma maculata.
Slight question then. With this ecological trap one, let's say you're sort of coming at it from a fix this situation perspective. Would it be a case of should modify the pool to aim for a longer hydro period and deeper pool? Or is it a sort of get rid of that pool so those amphibians that are returning to it can find another one which is more suitable? I suppose that's a practical question, but it feels like both would be options, right?
I think the best bet, if it's got woodland nearby, there's like an adult, there's a suitable habitat for the adults when they come out of the pool, then just make it deeper. Increase the volume, maybe put a liner in it, whatever it takes to stop it drying out and make it more suitable. Because, once you've dug that much of a hole, you've got most of the way, haven't you? You might as well make the hole bigger.
Vernal pool, fallacy or whatever. Yeah.
That's the sunken vernal pool fallacy. So, I think broadly speaking, there is some good news in here. And I think actually, hopefully this will be used as a bit of a guideline for people digging these pools because we can make them right. We just need to put the effort in. So thanks again to Kinga for this great suggestion. Hopefully that scratched the itch of vernal pools and salamanders. And have we got any other business this week, Ben? I think there's a little piece of business, isn't there?
Yes, I do have another little bit of perhaps optimism. There's not really much. There's not much to it. It's more just that in Bangladesh they are starting to release captive bred elongated tortoises as a way of sort of mitigating the loss of those guys. I think elongated tortoises are vulnerable, if not endangered. I can't remember how they're classed. Either way, certain areas they're having a really, really tough time from sort of over collection and habitat loss and things along those lines. But they have just released some in Bangladesh to try and help bolster the population in a national park there. Along with, Asian giant tortoises have also been reintroduced. So,
how many are we talking about?
6 elongateds and 10 giants.
I like turtles.
That's good. That's nice. So not huge numbers.
Not huge numbers, but it's they're undergoing a sort of soft release sort of process currently, where they're sort of in more restricted bamboo constrained areas for the next however long, and then they'll be sort of gently expanded and released into the wider park.
Happy days.
They will be tracked and followed to make sure that they're all right too. So.
Oh, okay. Do you know anything about
that? I know nothing about it other than what's written in the article. They do have a backup for when the radio transmitters run out too, which is mentioned, which is Clive. And Clive is a 4-year-old black Labrador who will be deployed to keep track of the tortoises.
Oh, mate. Big up, Clive.
Big up yourself. Keep it real.
Good stuff, man. All right, awesome. So there we go. Some nice happy conservation news to end the show on. And if people want to get in touch with us, you can. herphighlights@gmail.com is the address if you want to make a correction or ask us a question, whatever it might be. You can support us on Patreon, patreon.com/herphighlights. Thanks as ever to all our patrons. And we are on Instagram and TikTok at herp_highlights. You can find me on Instagram at Tom_E_major. Thanks for listening.
Thanks for listening.